Hi everyone, in this video you will learn how you can use Pythagoras in space. Well, of course, it's not really in space, but with Pythagoras in space, we mean that we can calculate some polydiagonals in 3D figures. So, for an example, calculate the length of CE, round to 1 decimal place. This picture is given and CE is our polydiagonal. So it means that it goes from one side of the room, so from one corner up to the room, all the way to the other sides of the room in the down corner. Alright, first of all, please have a look at the diagonal plane. So I can make a rectangle like this. So this is a rectangle. So please also think about what we did last paragraph with the cross sections. So this is actually like a cross section of the figure. So it's when you see it, the plane is a rectangle. So it looks like this. So A, C, G, E. If you found this, so the first step is to find a rectangle or a different shape where your polydiagonal lies in. So we do not know what AC is. We do know what E is, it's 4. We have absolutely no idea what EC is, and that's what we want to calculate. Alright, so what to do next? We of course know that this is also 4 centimeters because of the properties of a rectangle, and that this is also an unknown edge. We know too little to use Pythagoras, so we cannot use the Pythagorean Theorem. Therefore, we need to calculate one of the two things over here. It's not possible yet to calculate EC, but it is possible to calculate AC. As you can see, AC lies over here. So it also lays in a different plane. If you have a look at that, you can see that AC lies in plane ABCD. So in this plane. So again, I make a sketch of it, and it's a rectangle because it's a side of a cuboid. And we know that AB is 6 and BC is 3 centimeters. And of course, it's a right angle because that's one of the properties of a rectangle. So now we can calculate AC by using the Pythagorean theorem because we have a right angle. So a squared plus b squared equals c squared. So we have ab squared plus bc squared equals ac squared. Please remember that there's always the longest edge at the end, which is opposite to our right angle. So what we get is 6 squared plus 3 squared equals ac squared. 6 squared is 36, 3 squared is 9. So ac squared is 45. If you want to use ADC as a right angle triangle, that's perfectly fine as well. It gives the same measurements, so therefore it will also give you the same answer. So AC is the square root of 45. We do not round this, because you're never going to round something in between the exercise. You only round your answer, your final answer. So let's have a look what we now already know. We now already know that this is the square root of 45. So that's that as well. And in our big picture, this is the square root of 45 as well. Now we know 2 measurements. So therefore, we can use the Pythagorean theorem to calculate EC, since this is a right angle because of the property of a rectangle. Alright, so a squared plus b squared equals c squared, or short edge squared plus short edge squared equals long edge squared. So ae squared plus ac squared equals ec squared. 4 squared plus the square root of 45 squared equals ec squared. Please remember that the square roots and the squares are opposites of each other, so they cancel each other out. Therefore you get 45. So 16 plus 45 equals ec squared. And EC squared is then the same as 61. But we want to know what EC is, and therefore we need to take the square root. Now we are allowed to round to that 1 decimal place, since this is our final answer. Your answer when you type this into your calculator is 7.81024966. So therefore, our rounded answer is 7.8 centimeters. So please highlight this because this is your final answer. If you have any questions about how you can use the Pythagorean theorem in space, so in three-dimensional figures, please let me know. But please do not forget to always make 2 sketches, and then you need to do the Pythagorean theorem twice to find your final answer. Good luck practicing!